Everyone. So, what are we discussing today? Let me start the recording first because I don't want to fuck this up. Okay, so what happened is I was streaming one day, it was about a week ago, and I was streaming about semiconductors, right? Semiconductors and solar technology. But the stream ended because of some fluctuation in the internet, and what ended up happening was I lost all the content. I taught it for around 2.5 hours, but when I looked back into the stream, I just had 45 minutes of content available on YouTube, so I had to unlist that video because there was no sense of it. It was half information, and I don't want to share that. So I guess I'll have to re-record it again someday. But for now, yeah, that's just it. So what are we doing today? First, let's start the recording. Let's not forget that. And other than that, let's just quickly check out if our audio and video quality is right on the YouTube. So I go here. Just give me a minute here. Yeah, okay. So there is no noise and stuff. But it's all cool. So what are we doing today? So let's discuss. So basically, there is a lot that goes around into science and technology, right? Human civilization has reached to this point on the basis of the various developments that has happened into the fields of science, in the fields of materials, in the fields of technology, in the fields of the resource utilization that we have came up with as humans. The ingenuity that we have as Homo sapien creatures has what has led us to here. Let me quickly change the screen from here. I know this must be annoying because it's just an infinite loop of my face. So yeah, let me just quickly open note. Let's open a new notebook here. I don't know how to use it though. New notebook. Yeah, whatever. Science and technology. Oh my god, this is taking a lot of time. Wow, it's fine. So that's topics to discuss. Discuss. So what are we discussing first? So yeah, so I think the basic ingenuity that the humans have shown throughout their civilization, throughout the lifespan that we have been on this earth, has what has led up to this point that we are. We have so many technologies available. Even if you see at the thumbnail of this video, the thumbnail of this video is generated through an artificial uh, engine that is known by the name of DALI 3. So DALI 3, artificial intelligence basically on a major part. So artificial intelligence, what led to artificial intelligence? Well, the idea of artificial intelligence was started by, oh my god, yeah, Turing. So how did Turing start? So I don't know how many of you must be following science the way that I do. Like I know there are a lot of people around there, but and I'm nowhere compared to what all people have been working on and stuff. But in general, the audience that I have, I'm not sure how much do you focus on it. But let's just talk about it, right? Let's just talk about how it actually happens. So how many of you have read the paper by Alan Turing, the first paper? Let me show it to you. Yeah, is the paper available here? Well, basically, in the paper itself, he asked some very ingenious questions, right? Questions like a machine capable of learning itself, the machine that can use something similar to neurons that can shift. Like the questions themselves led to the development of neural networks, and the questions were so amazing that uh, when you are reading the modern content in terms of artificial intelligence, various books available, various, like you are working on a very abstract level when you talk about artificial intelligence. All these backpropagation, all this technology has been developed for you, right? And all these algorithms that have been worked on, tested on thousands and thousands of times has been served to you directly. But the paper itself, after you have learned all these high level concepts, after you have learned how all of this model making and use them in their own data like PyTorch, Scikit-learn, and all of this. After that, if you read this paper, this will open your mind so much. Like the first lines itself, I remember. Uh, yeah, let's read this. I know the print is really bad, and I find the paper itself. Oh my god, I should have did a bit of homework for this. Oh, is this the paper? Wait. Yeah, I propose to consider the question. Like, just read this introduction itself. I propose to consider the question, can machines think? This should begin with definitions of the meaning of the term machines and think. The definitions might be framed as to reflect, so as far as possible, the normal use of words, but this attitude is dangerous. If the meaning of the words machine and think are to be found by examining how they are commonly used, it is difficult to escape the conclusion. The meaning and the answer can to the question, can machines think, is sourced to be statistical survey such as Gallup poll. So yeah, I think me reading it doesn't really help, so I'll just give you a minute or two to just read this. Yeah, I think so that should be enough time to read this. So basically, the paper proposes a new idea to how we can check if a machine is capable of thinking or not. And I think a lot of development that had been having happening around this was not really leading to anything close that can help us clear the Turing test itself. But the recent developments into artificial intelligence that have allowed us text generation, image generation, video generation, and like, why is image generation, video generation, or text generation so important? Why does it seem to, like, why does this means that the machines are finally capable of learning? So basically, I think that it is so important because machines, if they are able to generate text, if they are able to generate videos, like videos themselves, like I know the video generative AI is not really that good right now. It is really good, like I know there are some impressive results available in terms of, like, in terms of the content available online or anywhere. If you go, you will see some amazing examples on YouTube themselves, the generated videos. But still, the idea of generating video means that the model is able to learn the data distribution of a video itself. Now what does it mean to learn the data distribution of a video? Now, okay, to understand that, let's talk about one more thing. Okay, I know I'm bringing a lot to the table, I'm talking about random stuff, but I'll bring it all to the conclusion, okay, slowly. So yeah, this question itself of able to imitate a person, able to understand how a person thinks, able to understand how a person would do something, and being able to fool a person, a machine being able to fool a person that it is capable of doing the same. And then the idea that the current AI, the frontier of science that is available, that are capable of generating video, generating audio, generating images, generating text. Now what does it mean to generate thing? It means that you understand the abstract concept of the data itself, you are able to learn the distribution of the data itself. Now what does it mean to understand the data distribution? It means that you are able to understand how the things work in real life. Now there is a very interesting book by the name Mind. I don't know the correct author of it, but I must have it here. Not sure. Yeah, The Brain. Sorry, The Brain. So The Brain is a very good book. I recommend it to everyone. Like, if you are into artificial intelligence, now I know this stream seems to be a lot more focused into artificial intelligence right now, but I'll be talking about a lot other technologies too, like in terms of mechanical engineering, in terms of material science. Like, material science is a fascinating field. If I had to summarize it in short, I would say that the civilization with the best material was always able to dominate the other civilizations, no matter what the number of population, no matter what the number of other resources that they have. If you have a better grasp on material science, like the people with iron swords were always able to defeat the people with stone swords, right? So that's the concept. Okay, so wow, that's interesting. That's cool. You were reading it just yesterday. I mean, yeah, you should read the original paper by Alan Turing. I would complete it. So yeah, so the book The Brain poses the idea that is very common in the the field of psychology study and understanding the human brain. But what this book basically says is that how everything is a perspective, how everything is a hallucination, right? Like, it is only that we call someone as hallucinating if they are seeing something that most of the other peoples are not seeing, and we call someone as sane or someone as normal if their hallucination matches our hallucination. So the brain just perceives things on the basis of different data that is inputted through the various senses that we have available, and how the brain constructs data. So if you see, there is a time gap between the data we take, like that it happens in computers too, right? So we have packets of data available. Like in a video is divided into frames. We have frames of video available. We don't have a whole series of video available at every second, right? So the brain is able to map the data distribution that it sees in terms of real life, and it is able to predict what would happen and fill in every gap. And we think like we are seeing a whole series of the data pattern, and we are not just seeing packets of data. So the brain is capable of doing it the same way a machine is. So if you see how a child learn, a child basically learns the distribution of data that is seen by it, right? That is perceived through its mind, that is taken as input through the various sources that are available to input the data. And the brain does that processing, and slowly, iteratively, our brain, the neurons available in it, the chemicals available in it, the hormones, all of these things learn the data distribution, and we are finally able to reach to the point where we can understand what it means, what different thing means in real world, right? So that's one interesting idea. So that relates to the idea of imitation game, right? So if a computer is able to take input from the outer world, if it is able to perceive that input, and slowly, iteratively is capable of learning the data distribution behind the data that is given through it in form of video, audio, and text, then it is basically has the capability of imitating a human. Now it basically depends on the data set, the online learning, the number of flops that you have available because of the GPU power that is being utilized, the number, how clean your data set is, and all of that crazy stuff. So there was one more interesting idea that I found in it. uh, uh, I'll have to find that. Just give me a minute. I'm sorry for wasting this time. Just give me a minute here. I read it a long time ago, so that's why I'm taking time. But basically what I remember is from the paper that it gave a very interesting idea to thinking itself, and how we can make machines that are capable of learning by uh, giving them the materials or the different knobs as such, so that a machine is capable of learning. Now I'm not able to exactly find that idea, that how it was presented, but I remember it was presented very beautifully in this paper. I suggest you to read the whole paper. Like, this is this is a very impressive paper. You would learn a lot about the modern day development into artificial intelligence because of this paper. Yeah, so basically, artificial intelligence, the idea that arose from Alan Turing's paper on computational thinking, right? And how it has progressed, how the idea of artificial intelligence started, right? What was artificial intelligence when it was just there? Like, it was used for some silly things, right? Like data prediction, regression, classification. Now these are really important tasks. Now these are really important to businesses for analysis purposes. This is really important for scientific purposes, for classifying the data set, for simplifying their other work. But now the field has progressed into the generative AI, and generative AI is a whole new story, because giving the machines ability to creatively think with the help of various models that are available, GANs, GPTs, and in terms of like DALI 2, uh, and like other diffusion models that are available, like what is in terms of diffusion model that is available, like yeah, basically diffusion models as such, as a whole. So all of these models that have led to generative AI are taking the field to a next field, because if a machine is capable of generating something new from the dataset that was given to it, that means the machine is able to abstract the distribution of the data in a much more precise manner than it was previously possible through the basic tasks like classification and regression. Like if you know about reinforcement learning, right? In reinforcement learning, it is commonly seen that the more difficult objective you give to the agent. Now, I know I'm not talking up from the basics of reinforcement learning, but if you give a difficult task to the agent, that agent would be able to perform much better. The able agent would be able to learn much more abstract details about the game or whatever environment you are using the agent in. If the task is more difficult, if the task is too basic, the agent would be quickly able to find a overfitting method or a convenient method so that it can fool the environment and generate the maximum reward. But if the task is slightly more complicated, the agent is forced to learn into more details. Same thing has happened with the help of generative AI. So advancements into generative AI and this whole idea of able to imitate humans based on learning the data distribution from the real life inputs can lead to a whole new story in terms of artificial intelligence, and leading more towards general artificial general intelligence, AGI, which is basically known as. So yeah, that's one of the details that we have to go through. And other than that, so reinforcement learning I'll include in that only, like reinforcement learning, idea of learning much more nuances and abstract detail about the environment if the task is more complex. Now, why is the task of generation complex? Like you would be able to see, like even in Japan too, like in Japan, in Korea, these cultures consider uh, the art, music, and painting to be a noble profession. Like if someone can is able to draw, if someone is able to create music, then it is a noble profession. Why is it a noble profession? Because they have a much more abstract detail about the social constructs. Like it is how it is seen, right? Like if you are able to generate a painting, a realistic painting, then you are much more uh, aware of the beauty of the nature itself, right? So that's the thing. That's why the idea of generating something becomes so important. Okay, so that's the idea of artificial intelligence, generative AI, reinforcement learning, and all of the uh, ability to uh, learn something better if the task is more complex and go towards the more optimum reward. Okay, so now let's also talk about some of the other advancements in machine in terms of science and technology. So one of the things that fascinates me is material science. Why is material science so amazing? So I would like to tell you a quick story about material science that just fascinates me like completely. Okay, so it's related to ice, basically. Such a simple structure, right? Ice. So what happened was there was this one man that used to live in the cold regions, and basically you don't have much business opportunities in the cold region, right? Because it's all ice. Like basically the most of the business they had was from fishing and stuff like that, because yeah, you have ice, you would have water, and you just cut down uh, holes in the ice, fish, sell that, export that, and maybe earn your living, right? And other than that, uh, yeah, so basically in the cold regions, right? In the cold European regions where you don't have much business. So basically there was this one man, and what he figured out was that if you reinforce ice with the help of sand, and if you create a perfect container for it, right, with the help of concrete, he used some air vacuum. So what he did was, it was a two-layered protection. So firstly, he used like sand reinforced ice to cover the outer periphery. Other than that, he also used a layer of concrete, right, and an air gap between it and another layer of concrete, which would prevent it, insulate it further from the external environment. And what he was basically able to achieve was that um, he was capable of exporting ice from Europe to various different countries through ships. Like we are talking about the time when it was not even possible to like export faster. Like there was no air travel. Like you're talking about air travel, right? Like there was no even refrigeration. It was that time, and the patients in different countries were dying because of not having refrigeration. Like there was this one case when there was a outburst of some kind of disease where a doctor was not able to save his or her patients because there was no way to keep their heads cool. Like there was no way to collect cold water. So he is the man who basically came up with the idea of refrigeration and stuff, but that happened way later. Before them, this man who came with the idea of reinforcing ice with sand and sawdust, I remember sawdust being a part of it, was able to export ice. And you will not believe it, but India used to import ice at that time when there was no like refrigeration possible. And obviously we were not that aware of the technology, so we were not able to export the ice from our own ice generating states, but we used to import ice from Europe that used to came through ship through the water, and that was sold here, and it was stored in specialized chamber with that same air gap. So right, so there is so much resource utilization that is achievable through material science itself. Like if you have a good grasp on material science, you would also achieve always achieve big. Like I gave the example of ice, right? But let's take the example of Apple itself. Like what does Apple do different than other phones or other businesses? Like one of the thing that I'm always able to see is material design. Like a lot of focus that Apple gives is onto the material they are using for their chips, the material they are using for their phone cover, the material they are using for their glass, the material they are using for their camera, the material they are using for their networks. Like all of this comes down to material. Apple has always focused on material. Their things are more expensive, they are more reliable because of the better material they use. Like their laptops, their mobiles always used to have lower RAM, lower memory than the other systems, other hardwares that were available outside, but they were still more expensive. Why? Because the customers trusted the material that they are using, and it showed that product life has increased exponentially, and the performance was way better than a 16 GB RAM of another company's PC, and a 8 GB RAM of Apple would perform way significantly better. Why? Because of the material, the idea, the thought that is going behind the material, how it has to be reinforced, how do we have to dope it, how it needs to be ionized, how much ionization is needed. Like all of these small nuances of material design makes it stand ahead from others. And not going even as far as Apple, but going into the earlier times, like I think that what happened during the, like everyone is aware of, like what it is called, colonialization. um Hello chat GPT, that's in my chat right now. uh well, I'm currently 20. I study in college. Yeah, I'm currently doing mechanical engineering from India. So yeah, so let me come back to where I was. So I think, yeah, so when I think about material science, one of the best example that I'm able to come up with is colonization. Like how was such a small country, such a small set of country, the European countries were able to take power, take control of so many other countries? What did they have that the other countries didn't have? Like they didn't have higher population, that's for sure. They didn't have a larger budget for military. Like there was no concept of budget at the time. Like there was no exports happening, there was no imports happening. So obviously it was not about budget. So yeah. Oh, that's great. Good to know, bro. I hope this session is useful for you. Do you have anything we can also discuss? Like anything you're particularly interested in, or I can keep ranting. Well, I like to continue where I was right now. So yeah. So okay. Yeah, the colonization that they were able to do at the time, like achieving that happened basically is they had slightly deeper understanding into the concepts of gunpowder, metal engineering, like the various manufacturing processes that are able to achieve with metal, and the various ways gunpowder can be used. Like they had a slightly better knowledge of it, and that led to the manufacturing of guns, bombs, and such stuff. Like, and that gave them power. Like the slightly better understanding of metal workings, manufacturing techniques, and gunpowder techniques, how it can be used for weaponization, and that slight more understanding gave them the power take over the world. And other than that, obviously they the navy played a big role in terms of colonization. Like the navy that they had was considered to be one of the best navies available at the time. The ships they were building were strong, and all that. So all that comes down to material science. So I think I'll put down colonialization, I guess. I must be wrong on the spelling, I'm not sure. Yeah, obviously, what's the correct spelling? Okay, so yeah, that comes down to the knowledge of material science. So why is material science so interesting, right? And basically, whatever I'm talking about, like, why am I discussing all of this, right? So basically, what I'm trying to do is I'm trying to encourage everyone that is watching this stream right now into the field of science itself. Like, why is it important? Why do we have to work on these stuff? What has happened? What can happen? What can we do with it? Like I talked about artificial intelligence, how it is capable of now imitating our understanding of knowledge, how it is capable of now understanding the distribution of data based on the inputs to such great details that it's able to go onto a creative side and generates its own content, right? So consider this, just a simple example. I just talked about material science, I just talked about artificial intelligence. Combine both of these. Now, what if you are able to generate, like, ChatGPT, right? How ChatGPT is able to generate text. Now, let's think about chemical compositions, lattices. Like, what if we were able to make a AI, right, that is able to generate lattices? Man, thank you so much. That compliment means a lot to me. Like, really. Thank you. That would keep encouraging me to make more of this content. So appreciate it. So yeah, let's just think about this, right? So, right. So how do we define a material? A material is basically defined by its chemical composition and the basic dopants we are using in it, the basic reinforcements we are using in it, the various the structure of its lattice, how that lattice is achieved through pressure, through heat treatments, or through whatever other technique that is available to us, chemical treatments and etc. So what if we are able to make an AI that can generate lattices and chemical compositions based on a task available to us? So basically, if I input to that AI that, okay, let's make a material. I want it to be this strong, I want it to be this flexible, I want it to be like this, and it can basically give us a material like, use this as the matrix, use this as the reinforcement, use these kinds of reinforcement with this fiber diameter, this matrix to fiber ratio, or this chemical composition, use these kind. Like, you literally have. Thank you, man. I mean, really, thank you. Okay, well, that's really appreciated. Yeah, so that's it, right? It's so crazy. Like, if you are able to generate an AI that can do all of this for you, like ChatGPT is an achievement. It showed what the AI is possible of. But if you think about ChatGPT, what is ChatGPT trained on? ChatGPT is trained on the whole of internet, right? Whole of internet. Like, let's talk about ChatGPT in itself, like isolatedly, right? ChatGPT, because it's a big topic, right? Like, not even ChatGPT, generative AI. So, what did generative AI teach us? I'll just like to, well, the research paper. It's actually, I've conducted the experiments. I have not shared the results with you guys. I know, like in the previous video, I was stuck in the end in the research, but I was able to change the code, and it was basically some silly changes and some silly bugs I had found. I would also be sharing them and also be teaching some nuances about the PyTorch that I've learned in the process that would help anyone. I think those are some beginner errors that anyone can make, and I have made them too in the video itself. So I think it would be a great learning resource for everyone trying PyTorch for the first time, and that I can make a video on it so that anyone can troubleshoot their PyTorch code. And other than that, so basically, I obtained the results on the standard data set that I was talking about in the previous video, and the results were satisfying. I had to share them. I'll keep them in suspense for now. But other than that, I currently have to work on it. I have to write the paper itself now, like write about the results, what the results impact is, and also talk on the interpretability and some little stuff based on the data set. So those are few of the results, and other than that, I'll have to repeat the experiments 3 times at least to show the repeatability of the results. Then to it's just the formality stuff, like you have to do that so that they trust you that you have repeated the experiments 10 times and these were the accuracy results so you were able to obtain. So basically, then they finally give you the approval that your result is trusted. So that's the stuff that is left. I'll be doing it on stream. So yeah, I'm not working on it on the background. I had to work on a couple of bugs in the homework part, but now other than that, all of it will be done on stream mostly. I think the some of the boring writing part I'll do off screen. So yeah, basically generative AI. I hope that answers your question though. That's the status on the paper. I know. Yeah. So basically generative AI. Generative AI teaches us that it is able to learn the data distribution. Yeah, I'm just showing off the pen that I've acquired for the streaming purposes that I'll be using in other videos, teaching videos that is more necessary, that makes the use of pen more necessary. So yeah, generative AI teaches us that data distribution learning is now possible. Now we have to exploit the extraction part of it a little bit more. Like a model is able to like encode this, like I hope you know about the encoder decoder networks. But basically, if we have an input in terms of images, our model is now capable of encoded this in terms of some vectors, right? So this image just means some vectors to our model. So if we are able to encode it, we basically have to work more towards the extraction part, and we can make some more amazing papers. Right, we can why am I saying papers? We can make some more amazing applications like we have seen with text generation and stuff. What happens when we are able to encode the data distribution in terms of vectors is that we achieve the capability of having a vector that is learned by our model and using it, yeah, like embedded databases. So basically, embedded databases. So in terms of embedded, do you mean like in terms of compression embedment? Like embedded means like, okay, I like, what exactly do you mean by embedded here? Like embedded can mean connected databases, like a database that is embedded in the system itself. But yeah, I think you basically mean is that our model, our generative AI models are capable of embedding our data set into some latent space and use that latent space as an embedded data set that can be used for other generation purposes. I think that's what you mean, right? Yeah. So yeah, that purpose, right? Exactly. So if we have compressed our data into some knowledge representation, we can use it for various methods. Like like you have seen applications. I don't know if you know about CycleGAN, but you can search for it, CycleGAN. So what CycleGAN does is very similar to this. So what it does is it compresses the data into some encoding, and then decodes it to generate a new style of an image. So you must have seen AI things like uh, image to anime generation, like image to anime type AIs and stuff. So that's basically it, right? That is using this encoder decoder network in some sense. Like it might be using other models for it, like diffusion models, GAN models, other GAN models other than cycle GAN, UNet based cycle GAN and stuff. But it is basically doing the same thing. Now, one more thing that is interesting, uh, in the same application, like I just had it in mind. Oh wow, oh wow. So yeah. Basically, if we talk about this cycle GAN stuff too, right? Like this encoder decoder network, this capability of transforming what data distribution space into some another data distribution space that encoded some other kind of network. So the image data distribution might look something like this, and the anime data distribution looks like something like this. So we are able to encode this data distribution into our own vector space, then decode it into this distribution space, and we are basically able to generate a converter. Now, what are the various applications? So let me give you a business idea, right? If anyone here is into business, right? Uh, like this can be your high selling idea. So yeah, listen closely, okay? I don't know. And this is something I recently thought of, and if you are ready to work in it, you can achieve some great heights with it. So basically, I'm not sure of the brand. I think I'll update you if you would ask me. I'll find it for you. So basically, there is this one brand of camera, right? It is a Japanese brand. So its lens are very expensive now. Like its lens costs in like cost like 100 above 100K dollars. So yeah, that's pretty expensive, and in Indian regards, that's a very expensive camera lens if you're talking about, and it's basically used in film purposes. And why is it so expensive? Why is it so rare? Right. So basically, the same company that sells this lens, what it did, what it made a lens around 30 to 40 years ago for a very standard camera, for a very basic camera of their whole team. And what they did was uh, 30 to 40 years ago, right? And what happened was when their camera got old, when their lens, the original lens that they made for substandard cameras, when the camera get old, because of some reaction in the camera, because of the years that pass, because of some decay, the lens shows some yellowish properties that makes this video more lively. And that experience has not been achieved through some filters till now. So basically, this lens is expensive because of the history this holds. And what's the history? That why is it expensive? That because you have to find a lens from that original camera that was sold 30 to 40 years ago. You have to check if there are no cracks. You have to check if the decay has happened in the perfect conditions or if it looks correct, and that makes the price for it. So basically, if you get a data set of videos, shoot it on a normal lens, a lens that you are using for your film, a cheaper lens that costs around 10K, and then use the data set of videos that are shooting using this lens, you would be able to train a AI. If you make a good enough model, you would basically be able to train a AI that can change this videos into these effects. So you are basically saving 90K dollars here, and even more than that. I don't know. You're basically able to save all of this money. You are able to convert that video, and yeah, like this is important to the field. Like if you are able to make that AI, I know it must be difficult. You have to come up with a perfect model. You would have to show the results because you know, Pika Labs. Not aware of Pika Labs. What is Pika Labs? Text to video platform. Okay. Yeah, so basically these kind of network, this is a text to video platform. Uh Text to video. I was not exactly talking about this. Like this is also something really important, right? If you like imagine the level of complexity that would be reduced if the director, rather than confusing the editor with all of the technical stuff and telling about visualizing it through text, can basically type the text into a AI, iterate it multiple times, and is able to show the product that finally satisfies the director, and show that as a prototype to the editor that this is what we are trying to achieve. You're right. And this idea is basically to convert one video format, one video that was shooted on a simple, cheaper camera. Like, okay, wow, I can keep ranting about this for so long. I didn't even realize it. I thought I'll be covering so many topics and I'll be running out of topics after a while. But okay, so there is this new technology known as GigaGAN. So, what is GigaGAN? Let's talk about this, right? GigaGAN is really interesting. Like, this is when I first saw the results of GigaGAN. Yeah, what's the lens called? Yeah, that's a good question. I'll update it. I'll I'll comment it in the video itself. I'm not really sure of what the lens was called. Let's just check it, right? Expensive camera of Japanese brand sold due to sold expensive due to its yellow lively effect. I think it must be here. Nah. Yeah, I guess it was Fujifilm. It was Chinese. It was a Japanese brand. I'm not sure. I think it was Fujifilm, but I'll update you on the correct name of it. I don't know where I read it. I read it somewhere. I'll go through it. I don't want to waste much time into it right now, but I'll update it in this video's comments itself. I'm really sorry I'm not able to tell you it right off the head. I'm really sorry. It's just completely off my mind right now. But okay, so this Giga again. So let me just show you something, right? Like this is a image, like this is the original image of some chameleon sci-fi art, right? Like it is 128 pixel image. Yeah, very basic. What's the stuff? What's the AI part of it? Let's just see what happens when it passes through a network known by the name of GigaGAN. This is the output image. Like I know, I didn't believe my eyes when I first saw the results. These results are out of this world. This is a 4K resolution image that looks crisp, clear, looks beautiful. Like this is this is perfect, and this is what it looked like. Like, are you able to see the level of details that the AI was able to put into it? Now imagine you have a basic camera. Now imagine business business ideas that you can have around filmmaking itself. You have a more cheaper camera that has a worse resolution. It shoots at a resolution of 720 pixels. I don't know, it costs around 1k dollars. So you first improve the resolution of it through an artificial intelligence like GigaGAN. You improve it to 10K and make it to the capability of 10K camera. Then you use another cycle GAN that is able to convert the video style from a simple 10K camera to a 100K camera using the AI dataset, and no one can challenge you, right? If you're able to replicate the results very perfectly, the artist wouldn't even be capable of finding the difference between both of them, because you are not using any filter, any human based like hue matching and stuff. You are literally using an AI to convert one video style to another, and if you have good loss, if you have a very less loss, then you have basically obtained the results. You have basically obtained the filter by itself without having to hard work through all of the different iterations, trying different hue filters and stuff. You don't have to go through any of that, and you are able to convert it through expensive camera. So you basically had to use a 1k dollar camera and you were able to achieve these kind of results. So this is the level of promise with generative AI. and all of this promises. So like this is a business idea in itself. If we work on it, if you give this enough time, this can turn into something big. We might even we can work on this on stream itself, now when I think of it, it might be a good idea to work on this on stream. It would be interesting to see how many of people would be interested in this. I know. Okay, we can work on this on stream. We'll see how that will go. But okay, so this can be a good business idea. Let me use another color for it because of OCD. Yeah, now it looks more colorful. Now I like it even further. Uh, yeah. So that was it. So yeah, I don't know. Keep I keep rolling back towards artificial intelligence. I know, but I just love the field of artificial intelligence, like artificial intelligence and mechanical engineering. Now, when people ask me why did I go into artificial intelligence, so much into the tech domain, so much specific, so much narrowed, like the people working in even tech. Yeah, yeah, I have Instagram and stuff. Uh, I would, I am on Instagram, what Facebook and whatever there is, I guess. Twitter. I don't basically use Twitter and threads that much, but yeah, I have an account on each of them. Yeah, I have Twitter. Basically, that's X now. It used to be Twitter. Well, yeah, let me see, right? I don't know what's the site for it. Okay, wait, I'm not gonna log in here. Let me just share the. Let me share my Twitter ID quickly. I'll put it on the chat itself. Uh, mm, so it's wow, it's actually very clean. I didn't know that. Yep, that's my Twitter. So you can join here. I basically don't post that much, but I can I come up with stuff. I'm not basically very active, but it's not like I can't be active or I don't have things to say. Basically, I'm ranting about the things right now that I have to say all of the time. I'm just giving a collective rant of it because yeah, it's just interesting to me, and I think if it's interesting to me, there would be people around the world that would find it this kind of brainstorming or this kind of idea analysis interesting. So that's basically what I'm doing right now. Yeah, that's where we were. This was the business idea. Now, yeah, when people ask me about why did I go so much in the tech domain, like people working in tech, even tech domain, don't really give so much into artificial intelligence right now, and they just they work on like the DSA part, the web development part, software development. There are so much people going in the software development industry, like seriously, software development, web development, React, Node, I don't know, all of that stuff, right? And like DSA competitions, puzzles, I find that really interesting, right? It's cool. It feels like chess to me, right? There is so much stuff that's available there, right? So yeah, just give me a second. Right. So there are so many people that are available in the fields of software development, web development. There is so much info that is available there. Like people are working there, like on the puzzles and stuff. And I find the puzzle stuff, like the DSA part, the competitive programming, code forces and stuff, really interesting. It's so cool. Like it's so cool. Right. But uh, what's the problem is, like, I think it feels a bit like chess to me, right? Like chess is cool. Chess is an IQ based thing. It's puzzles, it's brainstorming. You have to go so much in depth of ideas. You have to understand the whole process behind it. You have to keep learning it. You have to practice it. You can't just learn chess from book. You have to keep playing it for years and years to master it completely, to be able to win a few games. And then even that, sometimes you saturate your rating. It's difficult to jump above your rating and stuff. That's what happens in competitive programming and stuff. But do you think all of that puzzle parts really contribute to the society? It does in some sense, right? Like solving those problems fast on a time based basis, and you can come up with better algorithms. But how often do you come up with better algorithms and stuff? And I'm not saying that artificial intelligence is better for solving problems in terms of society and it is better to work on than software development. Like it is very important to develop our softwares, websites and stuff. That what at the end would be able to uh, present our artificial intelligence models to the whole audience. But the idea, like the frontier of science, these ideas, these look into what the future can hold and how we can reach there. This is what interests me. And the idea that I love mechanical engineering, right? I'm not the kind of person that is doing AI because I don't love mechanical engineering. I just took it because it is what was available to me at my rank, or like it's not like that. I love mechanical engineering. And my love for mechanical engineering actually pushed me towards my interest in artificial intelligence, because mechanical engineering has saturated the analytical brain that the human possesses. Like humans can only do so much calculations. Our brain is intuitive. Our brain has a hormonal or chemical feeling to it. Like we understand emotions on the basis of intuition. We understand concepts on the basis of intuition, on the basis of the data visualization, on the basis of the input that we have obtained in so much years from the childhood to our current age. And that's what it is. But when we talk about machines that have a purely calculated mind, like just think about this, right? Let's just think about this. Like it is so interesting to me. Like when you think about a basic classification model that is able to take an image of a dog, right? Just basically obtains a 3D representation of some vector of numbers in RGB, and it is able to use that numbers, multiply, divide, plus subtract them in such an interesting way that is able to tell if it is a dog or a cat. Like humans can never achieve this level of calculative mind using numbers to say if image is dog or cat. Or the same goes with chess. Like humans think of chess in such an intuitive way. Like this move will lead to this psychology. There is a lot going on, but the machine is able to think in a purely calculative sense. Like this square is this number, then this piece is some this number vector representation. If I dot product it with something, it will give me this number. The surrounding pieces are these numbers. If I plus multiply divide them, it gives me this number. So this move must be this much reward giving. Like this number of calculative mind is not achievable by humans. Like this is where AI assistants can take a part in. This is where the artificial intelligence technologies that are available can really shine, because then we would be able to achieve something that was not achieved before. And that is that in terms of mechanical engineering, we think the field of mechanical engineering is so saturated, right? Like when you go into studying mechanical engineering, you don't think about making a research paper. And if you are even thinking of a research paper, you are not thinking of creating something revolutionary or something from complete abstract, right? You are just doing a bit optimization, you are just trying some new models and stuff like that. But AI offers that capability that maybe we'll be able to optimize some things that were previously considered saturated, right? Like in the example, like I don't know, man. I don't know. Yeah, machines are primitive creatures. You are correct. They only learn from the input we give them. But the whole point is they are able to analyze that input in a very different manner than we do. We analyze an input based on intuition. We understand data in a very different way. So basically, if I give you everything about a car's engine, right? Like let's talk about the equations that are available to us, like the Reynolds equation, everything that we use in terms of mechanical engineering, Reynolds equation, and uh, Navier-Stokes equation. Like these are all considered approximations, and we use approximate results of these equations, right? These equations are not completely solved, and basically, human minds don't think like that. When you think of aerodynamics, humans think on a very intuitive sense. Like you can't consider pressure at all area when you are designing something. You have to think of the engine capacity too, like where you would keep the engine, how would the tires fit, and all of that. So it's not just that easy, right? And when we are designing something, we design on the basis of optimization. So we optimize our previous designs itself. We don't think of completely new things because we know there is a lot that is gone behind that, the engine capacity and the stuff. But the machines able us the ability that we can input these kind of constraints, and basically we might reach to a better optimization that was not thought of before. Because how the field started, because it will be able to think of something that was not seen before, because it doesn't necessarily think in terms of the intuitive sense that we do. Most of the results might be same because of the data that we are inputting, but it can still think of some creative things just because of the purely calculative mind or the purely calculative thinking aspect of it. So machines are primitive. They'll just learn on the input output that we provide to them, but they can basically extrapolate the data in much more calculative sense than we do. Just like I don't know, but you should see this documentary, man. Like if you are into AI, this is the first thing you should do. This thing. Where is it? Oh my god, where is it? Uh, go. Yeah, this AlphaGo. Man, this documentary, wow, just wow. The the progress we made through this Go playing algorithm, reinforcement learning in a completely different manner. This changed a lot in the field, and I think you should basically go through this at least once. It's beautiful. It's a beautiful documentary. You will love it. If you are even a movie lover, you will love this documentary. So basically, what it talks about is uh, how the AlphaGo and the Alpha chess were completely able to revolutionize chess and Go games, because humans who thought of those games in a very intuitive sense were never able to think in that much depth. And when the machines actually calculatively thought in that much depth, it was able to come up with new and completely unseen moves in positions that were seen before because of that calculative mind. So that same thing can be achieved in mechanical engineering too. So yeah, so that's the whole point. That's the whole point that I became so into artificial intelligence, even being a lover for mechanical engineering, because I think that the further progress that we can make in mechanical engineering can be assisted towards artificial intelligence, and the field that was previously considered a bit saturated can be pushed even further, even beyond its bound, with the help of the calculative assist that the AIs provide in general. Yeah, so that's the thing. So this is the calculative mind I am impressed by the most. Like this is the simplest example. This is the first thing you learn when you come to artificial intelligence, this classification model. But oh yeah, the Dota playing match. I know. I, was it Dota? I'm not sure of the game. It must be Dota if you're saying that. Yeah, but it was able to like destroy every game. And like the reinforcement learning, man, it just like reinforcement learning. I don't know if you know this or not, but reinforcement learning is a very old idea. Is considered to be one of the oldest idea in terms of artificial intelligence. But what DeepMind did was to bring that idea back with more recent developments in terms of neural networks and stuff, and collaborated that idea with the ideas of neural networks and stuff, and that allowed the reinforcement learning to be a generalized problem solving technique for so many games, for so many environmental based challenges. Like everything that you see, like the AlphaFold 2. Like I don't know if you have heard about AlphaFold, but AlphaFold was basically a protein folding algorithm, and protein folding is a very difficult task. It is easy to fold proteins of small sizes, but thus like protein folding, like it completely changed the field. Like there was this one example, like for a long time, a set of engineers were working on a bird specimen, bird's bone specimen that we had available to us. I'm just drawing a random bird here. So we had a specimen for a bone specimen for a bird, and we were not basically sure of what the bird is or what kind of diet it must have. We were confused due to the various factors, right? And it was not clear from the bone data itself. So when AlphaFold was released, it was able to fold the proteins obtained from that bone specimen of the bird, and we were finally, after so many years, were able to came to the conclusion of what the diet of that bird might be like. So it is helping so many fields. So many fields that were considered saturated are now being helped because of these kind of algorithm. And also, my favorite of it, like this is the most recent one too. I'm not sure of the name. I think it's Alpha Code. But are you aware of this? Like the recent development in term by DeepMind, uh, like it wrote an sorting and hashing algorithm. Are you aware of this? It's, uh, it's Vivek, right? ChatGPT is Vivek. So Vivek, well, okay. I think he's not here right now. So basically, there was this amazing algorithm known as AlphaCode. So it was able to write a code for sorting and hashing algorithm in the what is known as assembly level language. So, and it was able to optimize these basic algorithms that haven't been touched. These algorithms haven't been touched from 50 years and were considered completely solved. And AlphaCode came, it changed the algorithm. It changed a few lines of code, a couple of lines in the assembly level language itself, and it was able to optimize these two basic algorithms. Oh, hello. Hi. Uh, yeah. So basically this, right? So if you have heard about this, then it's cool. But yeah, basically this whole concept where we were able to optimize an algorithm that was 50 years old, using the latest artificial intelligence by teaching a machine to basically write code in assembly level language. Now consider how powerful that is. Like these algorithms haven't been touched for 50 years, and we were able to improve them. So yeah, so basically all of these things in terms of generative AI has completely amazed me. And yeah, you must have seen this, but yeah, I just wanted to tell the others about this amazing stuff that is available. Like you can work on this too. And also one of the key things that I think is open to work for right now in terms of artificial intelligence is that working on an artificial intelligence model that can prove stuff. So I think uh, a lot of intelligence that humans have shown are on the basis of able to use different disciplines and different fields to prove the concepts that are used in various disciplines, right? So basically when we talk about mechanical engineering or we talk about various designs, like we have seen how those designs have been mathematically proved through various equations, various pressure equations, geometric equations and stuff, and then we rely on it, right? So if we can basically, and the various algorithms that are used, like the various algorithms like back propagation and stuff are also proved mathematically on some data set, and some other proofs, some theorems that we use in our day-to-day lives, like Pythagoras theorem and stuff, like they were not just there, they were proved, and there was a whole discipline. What about philosophy? Like that's a very open-ended question. I'm not sure what you're asking. What about philosophy? Hello. I don't know. I think there is some latency. Yeah. So you're talking about AI in philosophy. Yeah, that would be interesting, right? So yeah, AI in philosophy. Yeah, that's an interesting thing to think about because you know, like humans are the only one that have questioned the way we live and how we live, what we live for, what's the purpose of living, what's the correct way of living. Humans are the only one that have argumented around this, right? That have put some points around this, uh, that has worked around this, right? Like you can't talk to animals, you can't get another input into it. Now this opens this questions of religions now, like the thing that I'm talking about, like there are various religions that talk about the different philosophies of the world that we live in. But the AI philosophy, when you talk about it, or if the AI, like you're mentioning right now, that AI has started to create its own philosophy, I think the philosophy that is currently being generated by AI, that is currently available in the market, it's just basically data distribution. Like again, when I was talking about chat gpt before, when oh my god, I'm so off topic right now. I just realized why I opened this slide up. But okay, when we talk about chat gpt right now, chat gpt right now is just it's just a text completion model. It's just generating text based on your prompt. How is it generating text? It is trained on a large chunk of internet. Now, what does it mean to be trained on a large chunk of internet? Now you know Reddit and stuff, right? You know what's the kind of communication going on in Reddit, in conspiracy theory channels, like all of that content that is available in the internet. And you know there is a large database of this content available. So when you talk about the philosophy, or if ChatGPT shows a different philosophy than us humans, then it's just basically the data that it has received through various mediums that talk about philosophy. And if you go on a Reddit philosophy page or stuff, you will find so many conspiracy theories, so many stuff. So it's basically those things that are appearing. The AI is not like, as you said before, right? You said itself. AI is a primitive machine. AI learns from what we teach it. So it's not learning anything on its own. It's not learning its own philosophy. It's not like Ultron right now. I know it's a dream. I know it's a dream if we are able to generate an artificial general intelligence that is as amazing, I'd say, as Ultron. But right now it is not capable of generating its own philosophy. It's just basically the things that is that's learned from the data itself, the various small nuances or the things, right? I hope that makes sense. Right. Yeah. So so basically, I think amazing frontier of science that is really open to work for right now is making an artificial intelligence that can prove things. So consider this: if we are able to make an artificial intelligence that, if we give an hypothesis to it, if I say x1 plus like if I give an hypothesis to this, if x1 is equal to x2, and if x2 is equal to x3, then x1 is equal to x3. Now I want this artificial intelligence to prove this theorem for me. Now, you know how these kind of theorems are proved, right? We use various concepts, like the concept of what is called mathematical. Uh, oh my god, I'm completely forgetting the name of it right now. Proof by induction, proof by contradiction. So, there are these few methods that are available to us, or by the basis of which we prove things, right? So if we use these kinds of concepts, if an AI uses these kinds of concepts and follow these basic steps that are used in these kinds of proofs and prove a theorem, if we give it, you have basically made a AI that can prove any theorem available to you. Now, how does that help? Now, consider this, right? That's when the interesting process actually starts. So, like, this is the really important part. This is the difficult part. Like, if you are able to encounter this, if you are able to make an AI that can actually do this, what you can do is you can make an AI that can generate random hypotheses on the basis of various data inputs. Not even random, generate preliminary hypotheses like ChatGPT. ChatGPT generates hypotheses based on the various data distribution that is available to us. So, if you use an AI that can generate preliminary hypotheses based on the small data set that is obtained by it and the sample data set, and it generates the hypothesis, and we pass it through our hypothesis tester, and they can iterate among each other till they obtain a new hypothesis that can be proven. It doesn't necessarily need to be new, but in the sense you are able to generate a new hypothesis for which you also have a proof available, which you can re-verify. So you have basically made an AI scientist by that point, and I think that's a really interesting frontier of science to explore if you are able to make an AI that can prove things. And I know if I discuss it in these terms, this must sound simple, right? Like there are some few constructs that are available to us by which we prove things. Now, the difficult part is that we use a lot of things when we are proving something. Like in maths too, you must have seen like we are using other theorems for proving previous theorems. We are using a pool of problems, hypotheses, and assumptions when we are doing this. So that's the difficult part. That's not easy to teach an artificial intelligence, but yeah, that's another frontier of science that you can explore. And like yeah, like material science, obviously I keep coming back to these things because material science is something that artificial intelligence can change completely. Like the level of detail, the level of atomic detail that we can obtain a material, a material, like imagine a material made for a purpose that has been designed atom by atom. The material is so perfect. I know it sounds expensive and all, and I know those are the other problems, but think of problems where money is really not a problem in terms of military based high precision applications, a one in a lifetime product or something. Like you will obtain such perfect model that you don't need to worry about anything else after that. Like that is the level of stuff that you can obtain. uh right. uh Wait a second, I'm still live, right? Yeah, okay, cool. So yeah, so material science, another amazing frontier of science that I think would be interesting to see how that goes. And I have some other things to talk about too. Uh, so did I open anything else here? So yeah, Gig again. I was talking about this was that application, and please give this paper a go. The Allen Turing paper, it's just amazing, right? And this was the prompt I used to generate the thumbnail for this video you are seeing right now. Like, see, this is amazing. I just wrote, please make a thumbnail for me for the YouTube video discussing the frontiers of science and technology, minimalist style, focusing on the mechanical engineering and artificial intelligence part. And this is what it came up with. This looks beautiful. This looks absolutely designed by an artist. Like 3D, the depth of it, it's just amazing. And I just had to write this, and it was able to generate this in a few seconds. I think it took around 30 seconds, but yeah, that deserves way more than 30 seconds, and it's a completely new image. Like it must not be there with anyone else. So yeah, that's amazing. And like I can go keep going on in terms of artificial intelligence, the various progresses that we have available. Like reinforcement learning itself, such an amazing topic, such an interesting topic when it comes to reinforcement learning, because reinforcement learning, I think, is one of those fields that can open so many ideas in terms of artificial general intelligence. Now I know there are a lot of criticism around reinforcement learning because of the data set hunger that it has, and the number of iterations it has to take to basically learn something. So it is not sample efficient. It is really not sample efficient. It is the least sample efficient learning algorithm that is available to us, I think, in the modern age. But still, the capability that it offers, the level it has been able to achieve in terms of gameplay, in terms of strategic gameplay, in terms of long term planning, in terms of these things, really shows something, right? This shows the capability of the intelligence that it is capable of achieving in terms of the control based environment specific task. And Earth itself can be considered to be an environment specific task that we humans are living in, with a reward function basically defined or different for everybody else. Now that goes into the philosophy part of AI, and how we can be some form of intelligence too for some other species, and how we are working on another reward function that is socially constructed through these many years. Yeah, that's also there. Oh my god, I'm low on battery. I'll just quickly come up with a charger. Give me a minute. I know this is not a good setup. Yeah, now we have the charger. Yeah, okay. So, as I was discussing, material science. Again, the amazing field. Now, what else is there? Right, it doesn't end there, obviously. Oh my god, how do I get rid of the pen? Text mode. Okay, cool. Yeah, material science. Amazing field. Air NPC AI. Actually, I've never heard of that. Let me just quickly check it out. Air NPC AI. Yeah, NPCs. Okay, you're talking about NPCs. I thought Air is a company or stuff. Yeah, right. NPC AI, that would be a game changer completely. Using chat GPT based models for dialogue generation and stuff, and maybe create your own story kind of games based on generative AI itself. Generative AI generates a new storyline or a new, like, map generation and all is just easy, right? But you can experience a completely different play of dialogues based on your input, based on your play. That's amazing. Like every time you play it, the replayability of the game is increased exponentially, right? You would want to try it another time and another time and another time, because it will be fun. It will be different every time. That's what you want. If you love a style of a game, you would keep playing it, replaying it, because it's different every time. So you just have to make a good style game, and it would be enough to encourage replayability. That's really cool. That would actually be a game changing. Yeah. Uh, yeah, so that's also something interesting. And other than that, and other than material science too, and I talk about mechanical systems. Plus, yeah, I don't want to talk about mechanical systems as a standalone, because the field has been saturated, as I said before. But with AI, I think this also, like, material science in itself is also really amazing, and there is a lot of things that has to be done, like the current work into the reinforcements, the new and new reinforcement that is coming up. Like, I don't know, but if you know about graphene, single layer graphite, it's just game changing in itself. Like, if you work on the manufacturing process, the with which graphene is produced, like, there is no good manufacturing process for it right now. But if you are able to generate graphene in mass production, if you are able to come up with a good manufacturing technique, and it's really easy, right? It's basically, uh, it's not that easy actually. I shouldn't say it easy, but it's basically more on the lower level, right? You have to think of a manufacturing technique. You have to think of various chemical based techniques, mechanical based techniques, and you just have to come up with a technique of generating graphene. And if you are able to achieve that, if you are able to make a mass production based graphene factory, you have basically taken over the tech, like completely. You will be right. You will not have lack of money after that if you are able to achieve that. Like really, like graphene offers the best abilities in terms of everything when it's compared to silicon and or other resistors that are available to us, that are heat sensitive, that causes problems like they don't work at higher temperatures. They don't have very good conductivity. uh, Gone, just completely gone. Graphene, best conductor that is available, a single layer graphene, very good conductor. Other than that, it can work at high temperatures. It would just change the game, completely change the game. So I think graph, uh, uh, in terms of material science, if we talk about, it's not just interesting with AI. AI is just an optional parameter that you can add to make more interesting materials, right? And mechanical systems plus AI is definitely a game changer. Like working for the different systems, like basically if you take the example of a car, then basically the engine, the exhaust, how those things works, what's the pressure difference, how those things are occupied, like then make simulations basically, and use those simulations to generate better designs for all of these different tools available to us. And yeah, that's also interesting. And other than that, uh, yeah, what was that? Oh my God, there's just something slipping off my head right now. Yeah, I think I'll come back to that later. Yeah, simulation and evolution. Why is it so interesting? Why is simulation so interesting? So consider this, and I know there is a lot of work that has already been done in this field, but in the past time, and we weren't exactly able to extract out something of much use. I know the evolutionary based bridge building algorithms and other algorithms are available to us and they work great, and there is a lot of work going into that. But I want to talk about simulation and evolution on a very different level, on a very interesting level, as if you might say. Like it interests me basically. But other than that, where I was before was like there has been a lot of work that has been done towards simulation and evolution in past. Like games are basically simulation, like the best example of simulations. The various engines that are available to us, Unreal Engine keeps uh, evolving into better and better simulations of the real world, the physics they use, the everything, right? These engines are available to us. But other than that, and the evolution part we have like worked on before, like various evolutionary algorithms used in mechanical constructions, and even games that work on evolutionary basis, like gene based games and stuff that has been worked on before. But consider a even more in-depth example of this. Like if we are able to take it to the next level, we try to construct a decent environment. We are able to construct some environment which we provide, right, and we basically understand the anatomy of uh, the single celled organism, any single celled organism with the least amount of neurons, and we basically use these neural network based evolutionary uh, uh, single celled organisms in this environment as agents, and their reward is basically the reward that was basically obtained by humans when they first started, that is to not die and keep their species alive. Those are the two goals, two rewards. Basically, there is no other reward. All of the other thing is generated by them. Okay, and we use these single-celled organisms. We allow them the ability to join in a specific manner, mutate in a specific manner, and all of these basic things, these bio things that have led to our evolution. We leave them in this environment that has been constructed by us, right? And we can obtain some interesting results onto how these species join together, how these species learn to survive, like how different civilizations with different resources, like so consider this as a civilization where a lot of water is available. Consider this part that is completely dry. Like what is exactly happened on Earth, right? Let different civilizations, because of their different geolocations and resource availability, have developed in a different way and have used different resources to reach different heights. And right, just as the Roman Empire uh, was able to be the best in construction just because of two things. First of all, their accidental discovery of cement, like literally their uh, it's so interesting, right? Like the soil they had, basically they dug some place out, and the soil there had the exact ratio for concrete, and they accidentally discovered concrete from that. And then they just they had some good architects too that were able to understand that the compressive strength of concrete is way higher than its tensile strength, and they were able to come up with a dome style designs that were capable of holding like large compressive forces and not good with tensile forces. So all of their structures remained intact for so many years because of their accidental discovery of concrete, which is a strong material. And right, so because concrete, good compressive strength, they came up with the architectural design that had a very high compressive strength and dome slash masonry. I'm not sure if it's called masonry. Wait a second. No, 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 not this, not this. Basically, what I'm talking about is this arc kind of structure, right? If you have seen like bridges like this, you must have seen these kinds of bridges, right? So this structure, this 2D structure is basically known as something that is slipping off my mind right now. So I'm just gonna erase masonry. That's that not what I mean. So basically dome type structures, right? That are able to handle compressive strength. So yeah, it's always interesting to see how different empires, different organizations, because of different civilizations, because of their different resource availability, their different approaches to life, and yeah, their geolocation are able to come up with different ways to survive and take on ahead. So yeah, that's really interesting to think about. So basically, if we are able to do this with some kind of in a computer controlled environment, we are basically creating life in some sense and are able will be able to understand the meaning of things in a much better depth. Now I know it's not clear how, but basically we can, if we are able to come up with such a simulation, we can also come up with simulations in much more depth, like that uses the data of atom itself, like going into such depths. Now I know it's very difficult because of the size of universe, the amounts of atom that are available there, and the butterfly effect, how one thing changes everything in the universe. Yeah, I know all of that applies, and that's just crazy to think about from such a high level, but still it's an interesting concept to think about simulation and evolution, basic using computers, and how far ahead we can go with that, how far ahead in terms of philosophy, and also in terms of like our research, because yeah, using those concepts in a much better depth and able to see what these different intelligent species that we'll be able to train, work with them, utilize them, in what sense. That's something interesting to look for. Yeah, basically simulation and evolution is also an interesting future field that we can look ahead to. And yeah, I think there are a lot of hype based products or things too that are going on right now. AR, VR. I know it's an impressive field, and I know I don't give much like not respect basically, but not weight to it. I haven't dwelled enough into it, and I know it's amazing, like the use of AR or even human-centered augmented reality, uh, right? That can allow us to basically save so many soldier lives by basically using a remote control based robot that uses a humanoid that copies or shadows the actions of a soldier that is sitting in a controlled environment, and using the augmented reality or mixed reality tool sets that are available. So that's also an amazing field that is available, and I have not given much weight to it, but that should come in the honorable mentions. I'll mention it here. AR/VR, amazing thing to look ahead to. So why am I not able to create lines? Cool. Yeah, that is also a honorable mention I'll keep here. And like energy too. Like if we talk about energy, uh, hi critic. Hello. Hope you will enjoy the stream. I've gone through a lot of topics already, and this was basically a lot of ranting here. So, yeah, hello. This is not the general kind of a stream I do. I know you guys mostly have seen me through research papers and stuff, but here I just wanted to rant out about things that are interesting to me in terms of science and technology, and where I see the field going ahead. What's the use of the different things that are currently being worked on, and what are the available things that are there that you can work on yourself to get ahead of the things and work on the frontier of the science itself, because these things motivate me to learn more and work ahead in the field. So with this video in the stream where I was talking about all of this, just I was just trying to motivate you guys too, that you should also work in this field, because just look at how amazing it is, right? So yeah, let's move on ahead. So yeah, I was talking about, oh my god, I completely forgot, like the energy, right? Like energy is a big thing. Energy is something, like is energy is a metric of human civilization advancement. Like, because if you see, like, it is commonly seen that countries with high energy utilization are countries with more industries and more advancements, more economy, better economy. And why is that? Because energy led to industrial revolution, and industrial revolution increased the use of energy exponentially. And that energy resources are depleting. The energy resources are not infinite, especially the non-renewable ones. They are obviously not infinite by the name itself. So that poses a problem. What kind of problem does it pose? It basically poses the problem of how would we keep improving if the energy resources would be out. So basically the various energy methods that we have available, and the most interesting of them being the solar energy. Like, it is really interesting, right? The amount of research that is going on in it, and how you can use even AI in it if you are into AI. I know a lot of people here must be into AI, because that's what my research paper was about, and that's what the audience came from. But yeah, you can use AI in it, you can use basic electrical and electronics knowledge into it, and even mechanical engineering on the basis of production, and various mechanical manufacturing, mechanical, like, in terms of why am I keeping manufacturing separate from mechanical? In terms of mechanical, I mean the various structures that it can be mounted on mechanically, the design of it, so that it allows for more energy extraction from the sun. So basically, those kind of capabilities. And electrical and electronics are obvious in terms of the photovoltaic effect, how we can improve it, how we can improve the efficiency, what material we can use. So it also relates to material science. Like, material science basically comes down to everything, right? Because when it comes to anything you talk about, material science can improve the efficiency of anything, because the level of material you have available defines the level of product you would have, basically, in simple words. So that's there too, right? Energy obviously being the important field in terms of future. It is always important, right? Yeah. So those were the things that I wanted to discuss. Now I can keep on ranting about reinforcement learning and go through various applications and, like, you know, there are so many things that come up every day, like the papers. If you go through the ML papers, like, you receive so many papers each week in terms of AI and ML, and the field is rapidly improving. So there is a lot to go through. There are a lot of applications. So basically, we can't cover each one of them in this video, but I just wanted to give a basic idea of some of the things that I was aware of. Now, I haven't covered all of it here, but I think we can keep streaming ahead and we can have these kinds of brainstorming kind and idea discussing type streams. I think it is a good idea to motivate everyone from time to time into the fields that are available, and what is the work that is being pursued in them, and what are the various ideas that are available to us that we can work on ahead to take the field ahead or make various applications in terms of businesses too, and make money from it, right? That's a good objective to have in mind. Yeah. So there's that. And other than that, I was also thinking about, uh, I would be streaming about the research paper. I have to give updates on it, and I have completed the experiments too. So I have to explain what were the mistakes I was making before that were causing issues in the previous video. So basically, for that, I think I would be making a video where I would be talking about some various different troubleshooting methods on a PyTorch project. I think those are some important learnings that I took from my experience using PyTorch, and I think any beginner that is just starting to use PyTorch might face them as I face them. They are not generally taught in books and videos, so you are not able to correctly find them. You learn them through Stack Overflow or through multiple iterations and experiments. So I think it would be helpful for anyone that is just starting out there. So I think that's there too. Yeah. मेहंदी लगाई है मैंने. So yeah, that's also one of the important things. Or yeah, I think I should end this stream here, and we will do more of these streams where we'll be discussing idea. And other than idea discussion stream, so basically this stream was an idea discussion stream, right? We were discussing various ideas, various applications that are currently being worked on, that can be worked on, right? Various application based ideas, various research based ideas, and what has been happened before, what in different fields is fascinating, and why is science something that I love so much and I want to uh, devote so much of my time to. But other than that, uh, I think uh, we will also do some brainstorming session based streams where we will focus on a specific topic or on the fields that we discussed, or something other than that that I come up with or talk about in some other idea discussion stream. And yeah, we can brainstorm on it together. We can think of some ideas, work on the problem from scratch, learning on the way, and also might be creating something new and unique. Who knows? Right? We can just brainstorm some ideas, come up some creative solutions, and try to make it work. Do some experiments, make some experiments, test them. All that interesting scientific part. Yeah, this is where I'll be ending the stream. I'll be sharing the name of the lens with you just after the stream. I'll keep it in mind. So don't worry, Vivek. You will get the name of the lens in the comments of the video itself. Yep. Uh, thank you.